Yeah. From the fx graph, the force applied F is directly proportional to the extension x. Okay, F directly proportional to x, or F equal to kx. So, what is k? K is the constant of the spring. The spring constant. That's k. So, k we can get from the gradient of the graph. From the gradient of the graph. M is gradient, so M equal to spring constant. Ni ulang balik, revise balik. Okay, now we go to calculation. Physics ni ada banyak calculation, sama dengan yang belajar AdMath. AdMath pun sama juga dengan physics, sama juga dengan sains. Ada dia punya acceleration dan velocity semua kan. Semua apply dalam question. So benda sama je yang you belajar. Semuanya formula lain-lain. Formula lain-lain. Kalau math, cara math. Physics, cara physics. Okay, number 1. This one, dia punya level rendah. Dia bagi dah graph, given you the graph. The graph shows the relationship between force and extension. Calculate the stiffness of the spring. Stiffness of the spring. How stiff the spring is. So, stiffness here refer to the spring constant. And this one refer to spring constant K. Okay, the question wants you to calculate the spring constant K. You are given a graph fx. Now, how to find K? How to find K? So,
F equals kx.
Okay, you can use the equation F equal to kx, right? But here you are given the graph. So, you just follow the graph where how to find K is by calculate the gradient of the graph. Calculate the gradient of the graph. So, find the gradient. Ini macam biasa yang buat dekat AdMath. So, gradient dekat sini. Kalau Math you belajar how to find gradient. Y2 minus Y1 equal to X2 minus X1, right? So, same physics also. We have 40 minus 0 for Y and 4 minus 0 for X. So, K 40 over 4. And the spring constant become 10. 10 Newton for force, unit for force, and centimeter negative 1. Newton, centimeter negative 1. Okay, for the unit. Unit mesti tulis ataupun you just write down here. Newton cm. So Newton cm negative 1. Okay. This one we use graph. We use graph. We use graph to find the spring constant K. Otherwise, we can use F equal to Kx if there is no graph. Okay. For example, number 2. A spring with an original length. Okay, you just state in the question. Tulis terus apa yang info yang you dapat. So, original length LO equal to 10. Compressed to 9 cm. So, this is the final length. But a load of mass 0.2 kilogram. This one is mass, not weight. So, A, find the spring constant. We don't have graph, so we use the equation F equal to Kx. So, how to find the spring constant? What is F? How to find F? How to find F here? Macam mana nak cari F?
LO minus LF.
LO minus LF. That one is X. F. How to get F? We want the question want K. The question want K. So K equal to
X times 10. F mass times 10.
Yeah. So F equal to weight. F equal to weight. So weight equal to mg. Mass time gravitational acceleration. So tengok dah ada 0.2 times 10, so 2 Newton over X. How to get X? Extension is the difference in or change in length. Change in length. Final minus original. So 1 cm. X is 1 cm. Dia compress until 9, so dia punya X, dia punya length become shorter. The difference is 1 cm. So 1 cm. Now K is 2 Newton cm negative 1. Okay. Easy, right? Okay, setakat ni easy lagi lah. Okay, tengok B. Calculate the length of spring if the load mass 0.2 replaced by load of 0.5 kilo. Okay. Calculate the length of the spring, mean final length. Calculate the final length of the spring if we replace 0.2 with 0.5 kilogram. Macam mana nak buat ni? I use the same equation, F equal to Kx. So, F, how much is the F, the value of F?
5.
Okay, 5, 5 Newton. Okay. Okay, mana dapat K? We have calculate the K at 2A. So, you just substitute the K, which is 2 Newton cm negative 1 and X. So, X, the punya extension of the spring become?
5 over 2. 5 over 2.
5 divided by 2. Berapa?
5 over
2.5.
2. Oh, you want decimal lah, Cik? Oh, sorry.
Dia punya answer lah. 5 divided by 2 berapa?
2.5.
Yes, 2.5 cm. We use cm, right? Okay, kita guna cm. So, 2.5 cm. Okay, now, 2.5 cm is the extension of the spring when we replace with 5 Newton. The question want the final length of the spring. So, how to find the final length? LF, or you can use L. How to find the length? This is a compress, means that you put the load on the spring, not you hang it on the spring. You put the load on the spring.
10 minus 2.5?
Yes, you must minus. Kalau compression, the spring becomes shorter, so you must minus. Okay, so 10, original length is 10 cm minus 2.5 equal to 7.5 cm.
Cik, LF2 is the 10
Apa dia?
LF.
LF final length.
And then LF atau L.
Boleh guna suka hati lah nak guna simbol apa. Saya suka guna length final, F final. So LF ataupun kalau dalam buku teks dia letak punya pemanjangan spring ni sebagai L. Okay, mana-mana boleh. Asalkan you punya final answer tu betul dengan unit. Okay. Number 3. Okay, number 3, the diagram shows the extension of a spring when it is attached to two different loads. What is the original length of the spring? Okay, nak cari L naught ataupun L dekat sini. Ori dia berapa original length dia? And then the question give you two different load with two different extension of spring. 2 kilogram, 5 kilogram. So how to find the original length? Macam mana nak cari ni?
Sekejap cikgu, dia always 10 cikgu. Yang for 10 tu is from the L, is it?
Yang mana? Yang second tadi
Yang 10 tu.
Yang 10 ni daripada soalan asal lah. 10 cm L0 ni. Number 2.
Oh, okay.
So number 2 ni dia continuous kan soalan.
Okay.
Soalan dia bersambung. So guna maklumat yang ada dalam soalan. Unless it give you the another value for original length.
Okay.
Okay. Number 3 ni. We have two different load, two different length, 15, 17.5. So how to get original length of the spring? So for this one, you need to find the extension for 1 kilogram. For each kilogram lah. Okay, for each kilogram. So after that we can minus to get the original length without any load. Without any load. So how to get the 1 kilogram extension for 1 kilogram? We need to find the extension for 1 kilogram. Macam mana dapat tu? Okay. If you hang 2 kilogram, it become 13 cm. If you hang the spring with 5 kilogram, it becomes 17.5. So we can see here that in difference in 3 kilogram, okay, let's say from here to here or to here, okay, this one, the extension for 3 kilogram, right? Beza. We compare 5 and 2, so 3 kilogram, and then dia punya extension from 17.5 to 13 cm. So we can find for 1 kilogram. Boleh? Okay. So dia punya comparison for 3 kilogram. Berapa dia punya extension? 17.5 minus 13. So we get 14.5 14.5 cm. 14.5 apa pula ni matematik. 17.5 minus 13 become 4 Okay, 17.5 minus 13. The extension here become 4. 4.5 cm for 3 kilogram. Okay, so for 1 kilogram, the extension is 4.5 divide 3. Now we get 1.5 cm. Boleh? Boleh faham
Okay.
So 1 kilogram is 1.5 cm. The spring will extend to 1.5 and 1.5 for 1 kilogram. So for 2 kilogram here, it will extend to
3.0.
3 cm. Boleh?
Okay.
Kita ambil salah satu. We want to find the original. Okay, so we just take either one lah. Let's say we take for 2 kilogram, the extension become daripada sini. So dia punya extension for 2 kilogram become 3 cm. Now, to find the original length, we just minus. Salam. Postman pula. Sekejap kira tu. Yang letak je. Letak dia. Dia. Okay. Berapa dia punya original length? Tak ada. Ni Abah. Abah tak mana.
10 cm. 10 cm.
Huh?
10 cm.
Yes. Okay, 10 cm. So you got 10 cm, 13 minus 3. 13 minus 3, so we get 10 cm. Original length is 10 cm. Boleh?
Sekejap.
Boleh ha? Yang ini pun samalah. Kalau you kira for 5 kg also, you can get the same answer.
Oh,
Ada soalan? Nak tanya yang ini? Cari je beza. Berapa beza and then you find out for 1 kilogram. Cari untuk 1 kilogram. Lepas tu baru kita tolak. Ya, kena tolak lah sebab this one dia makin panjang. Yang nombor 2 tadi dia makin pendek. Yang ni dia makin panjang sebab dia gantung dekat bawah. So dia akan jadi makin panjang. Extend longer. Kalau compress baru shorter. Okay. Ni pun dah belajar elastic potential energy you get from the area under the graph. Area under the graph. Okay. Present the elastic potential energy. We have two equation. Half Fx and half Kx square. Ada soalan nak tanya yang persamaan ni? Ada? Okay, factor that affect elasticity, we also have learned four factors. Number 1, dia punya length, either shorter or longer. So which one has a higher stiffness of spring? Shorter one or longer one?
A.
Huh?
Shorter one.
Yes, shorter one. Okay, shorter one. It's harder to extend or compress. So A more stiffer than B. Okay. Diameter of coil. Diameter of coil. Not diameter of wire. Okay, diameter of coil, smaller diameter of coil and larger diameter of coil. So which one is more stiffer? A or B?
Smaller.
A. Yeah.
Okay. Yes, A. So smaller diameter of coil are hard to extend. So A more stiffer than B. Okay, susah nak extend. So dia punya X pun akan jadi pendek. Dia punya extension smaller than B. B boleh tarik panjang. A tak boleh tarik panjang. So for the stiffness you can use higher. The word higher or larger or bigger. Okay, higher, larger, bigger. Moderate tak ada. Middle tak ada. Either higher, lower, smaller, bigger. Okay, this one next, the third factor. Okay, this one diameter of wire, the wire itself. The thickness or the thickness of wire. The thickness of wire. Ini kita boleh guna sama ada thickness, thickness of wire or diameter of wire. So which one more stiffer? Smaller or larger diameter? Dia punya diameter of coil sama. Yang dekat lubang ni sama besar. So which one is stiffer? Large diameter or smaller diameter? Spring kasar dengan spring halus. Yang mana susah nak compress or extend?
Kecil punya.
Kasar. Kasar.
Yang kasar. So yang besar lah. That have large diameter of wire. So this one is B. Okay. And then less stiffness is A. Higher stiffness is B that have large diameter of wire, yang kasar, yang tebal. And this one, the type of material or type of spring, either it made from steel or copper. So already state here, stiffer and softer. So this one should be A lah. Steel more stiffness than copper. Okay. Okay, steel, besi dan campur dengan besi kuat. Copper ni kita guna untuk buat electrical wire. Okay, now this one, spring arrangement. We have two type of spring arrangement, ada in series and parallel. Ini pun saya dah explain. So for series, dia punya total extension we must time with how many spring use. So this one X, this one become 2X. So this is 3X. Dia punya value of X sama. Value of X sama. Right. For parallel arrangement, total extension you must divide with how many number of spring. X over 2. If 2 spring. Okay, if there are 3 springs, so X divide by 3. So dia punya extension become smaller and smaller. Become smaller and smaller. Dia punya force pun sama lah. Okay, let's say this one have, we estimate this one have 1 load. This one got 2 load. So F divide by 2. This one F divide by 3 for dia punya tension or force. Pun weight. Okay. Di sana ABC. Okay. Baik, tengok soalan betul-betul. Yang ni ada ralat sikit soalan ni. Okay, nanti bila you tengok balik soalan, okay, you tukarkan, you change the 20 gram into 200. 200 gram. Sebab 20 gram ni the value is too small. Macam tak logik. Yang ni kita guna dalam gambar ni kilogram. Okay, so dekat soalan tukar 200 gram. The diagram shows two set of identical spring. Kalau ada perkataan identical spring means that dia punya spring constant is same. Jenis spring sama, panjang sama, factor tu semua sama. Semua sama. So identical spring. P and Q use the same spring. Okay, with different arrangement P and Q. The original length of each spring is 5 cm. Okay, dia bagi tahu L not equal to 5 cm. Original length is 5 cm. With a load of 200 gram, the extension of spring is 2 cm. Okay, 2 cm if we use 200 gram of load. Okay, now find the length L of the springs in P and Q. Where is L? So L from the length for the whole system in P and in Q. Dia nak cari panjang keseluruhan when we put load. Okay, now how to find this one? Macam mana nak cari ni? Ada idea tak? Okay, kita separate untuk P and Q. Kat sini ada dua jawapan lah untuk P1, untuk Q1. Macam mana nak cari? Okay. Kalau soalan keluar macam ni, kita guna ratio. Kita guna ratio. Kita boleh guna ratio. Tak payah cari K. No need to find K. So for this one, two different load different arrangement of spring, we use this one. F1 over X1 equal to F2 over X2. Okay? Or we can use mass. Nak guna dalam Newton pun boleh, tukar mass kepada weight pun boleh, ataupun we just use the mass given in the question, M1 X1 equal to M2 X2. Okay, ini dia punya equation untuk cari soalan, untuk cari jawapan bagi soalan yang macam ni. Ada dua, got two different system. Okay, now for P. Okay, how to get dia punya fixed variable already given in the question. So kita cari yang fixed, yang dia punya extension, original extension of the spring. Okay, so we use M lah. Senang guna M. So 200 gram. Okay, 200 gram. Convert the unit into kilogram. Convert the unit into kilogram. Mesti guna unit yang sama. Bila dah substitute into equation, pastikan unit mesti sama. Kalau kilogram, so this one you need to convert to kilogram. 0.2. 0.2 kilogram, okay, over X. Dia dah bagi X. Kita tak boleh nak cari X lain. So kita hanya ada yang dah diberi pada soalan. X equal to 2 cm. So 2 cm. Okay, and then what is the extension of P? Kita nak cari extension untuk each spring in system P. So what is X? Kita nak cari dia punya X. So now in P we have 3X, right? 3X. Okay. So find for one extension of spring first. Now we use 40 kilogram for M2 and X2. X2 we want to look for. So X2 is, ini kacang ini punya mat ni. 40 times 2 divided by 0.2. How much is the extension? Siapa kalkulator tekan? Siapa ada kalkulator dekat depan?
Okay.
Ataupun pakai otak je. Siapa mat highest? Highest dekat sini. Mirsyad? Senyap lah Mirsyad. Mana Mirsyad? Berapa X?
Mishat dekat kelas lain cikgu.
Mishraf. What's the value for X2? What we got here?
Sekejap.
How many cm? 40 times 2, 80. 80 divided by 0.2.
400.
Okay, 400 cm. Okay, 400 cm. Ni boleh tukar kepada meter lah. Kecil sikit. So we have 4 meter. This 4 meter for 1x. 4 meter for 1x. For 1x. So we have 3x here, right? So total x 2 equal to 12 lah. 4 times 3 because we have 3 spring. 3 spring. So total extension is 12 cm. Right. But the question, look at the question again. The question want you to find the length, not the total extension. So the length for system P is 12 plus the original length of each spring, 5, 5, 5. And we know that the original length of each spring is 5 cm, right? So we just add 3 times 5 equal to 15. So this one we use cm. Ini tadi meter. Meter, sorry 4 meter times 3 equal to 12 meter. So 12 to 1215 cm. Okay. Ini sepatutnya 5 cm ni tukar kepada meter jugalah. Sebab tak logik. 1000 sampai 1000 cm. Okay. Ini 5 cm ni. Patutnya meter ni. Okay, tak apalah. As long as you understand. So this one is 1200 cm plus 15 cm. So ini dia punya jawapan. Okay. Right. For Q. Okay, this one settle. For LP settle. Now we look at Q. Okay. Q ni macam nampak macam complicated sebab we have combination of parallel and series. We have single spring here which is X. Okay, X. Okay. And then dia punya for double X over 2. Okay, X over 2. Boleh Okay, now we look at Q. We look at Q. Then dia punya load are different. If Q use the same load as 40 kilogram, we just we can use on this one the value, this value 4m, 4 meter or 400 centimeter. Okay, kalau dia guna 40 kilogram juga, kita boleh guna extension untuk 4 meter. Now it use a different load, so we need to find dia punya extension. Extension yang lain lah. Okay, so untuk Q sama juga guna ratio 0.2 kg over 2 equal to okay, look the load for this system is 60. Now in parallel, you still remember the equation for tension? For parallel, we must divide. We must divide the tension with the number of spring used. So we have 2 spring. So 60 kilogram become 30 kilogram untuk parallel. For parallel, okay, untuk yang parallel dekat atas ni, dia punya weight kena bahagi dengan 2 ataupun mass bahagi dengan 2. So it will be 60. 60 kilogram over X. Now we want to find the X. The X here. Okay, the X here. Okay. Right. So, berapa X? Berapa X?
3 meter.
300.
300.
Okay, 300 cm. Okay, use cm lah. 300 cm. Nampak macam besar sangat 300 tu. Spring tu nampak kecil je. Okay, now we got the X for the parallel one. No need to divide anymore. No need to divide. Just divide for mass only. Okay, now for series. Same method. 0.2 divided by 2 equal to 60 lah. We have single spring. Single spring in series. So 60 divided by X. So X equal to 600 cm. So total extension tambah become 900 cm and plus the original one. Here is 5 cm and this one also 5 cm. 5, 5, 10, 5 cm, okay, 10 cm. So equal to 910 cm. Okay. Boleh tak ni? Ada masalah tak? Jangan lupa bahagi. Bahagi. Untuk yang parallel ni kena bahagi based on the number of spring. This one no need to
10 cm
divide.
tu daripada mana cikgu? 10 cm tu from the length of the spring, is it?
Yes.
Okay.
10 cm ni 5 tambah 5.
Okay.
5. Original length of the spring. We have to kita tengok dua. Spring tu dua dekat sini ya. Dia punya length tu. Okay, bukan 3. Even we use 3 spring, but the length refer to 2 spring only. 2 spring. Okay, because the other one is connected parallel. So 5 plus 5 plus 300 plus 600. Boleh. Ini tak logik sepatutnya. 5 cm ni kita tukar kepada meter. Okay. Cuma cara tu sama. Cara dia sama saja. Okay, guna ratio. Soalan pun dah salah. Okay, next. Number 2. This one easier. We have spring constant K extended to a length of 2 cm x. Calculate the work done in stretching the spring. Work done. How to find the work done? Work done. Where the work done come from? Work. Still remember the equation for work? Work equal to?
G?
Displacement times time.
What?
Displacement times time.
Displacement time. No. Work. What is work?
Beban. Wait.
What is work? Work equal to F times displacement, not displacement times time. Work is the product of force and displacement, FD. So equal to Fx. What is Fx? Fx is the energy. So calculate the work done in stretching the spring means that you find out the energy of the spring, elastic energy of the spring. Okay. So tukar dekat sini, work done for spring is half Fx. Half Fx. Kalau Fx sahaja untuk motion. Yang ni untuk motion. Work done. Daya, darab, jarak. FD ataupun Fx. Okay, boleh? Okay. So, F not given in the question. We only have Kx. Kx. So, we change the equation equal to half Kx square, half Ks square. Just substitute into the equation half time 450 Newton meter. Sekejap. Ring. Bibik ring. Okay. 450 Newton meter. Meter negative 1. So, look carefully for dia punya extension. It used 2 cm. 2 cm you must convert to meter. Jangan terus masukkan. Jangan terus letak 2 cm. So, this 2 cm you must convert to meter. Tukar kepada meter dulu. So 0.02 meter square. Okay, cari berapa? How much the energy needed to stretch the spring? Ada calculator tak?
0.09.
0.09.
09. 9.
03.
9. 9.
Okay, 09. Unit is? Unit for energy. What is the unit for energy?
W.
Watt.
Hai.
Watt.
W is watt. Watt for power. Energy unit apa? Sama dengan work.
V.
Apa unit untuk work? Ah,
Joule. Joule.
yes.
Oh.
Joule. Okay. Unit for energy is joule. So 0.09 joule. Okay. Ataupun kalau susah nak ingat unit for energy, you tengok balik apa yang you guna dekat sini. Newton, meter, -1. And then meter. Meter square lah. Sebab you square dekat sini. So meter square. Newton meter -1 times meter square equal to Newton meter. Right. Kalau tak tahu, tak boleh nak fikir apa dia punya unit bila exam nanti. So you just follow the unit in the question. Make sure you multiply with the correct method. Kira dengan betul. Okay, number 3. The diagram shows the force extension graph for spring. Calculate the elastic potential energy. Okay, find elastic potential energy stored in the spring when the extension is 3 cm. Okay, when the extension is 3 cm. So ini kalau dia nak minta you lukis dekat graph ke, so you just follow the graph. So, okay, so for energy is the area under graph. Okay, E equal to half Fx. Because we have F, we have X. F and X, so half Fx. Okay, F berapa? 43, so 30. F is 30 and X is 3 cm. 3 cm. Now follow the equation. 3 cm is 30 Newton. 30 Newton. So berapa?
45.
Okay, 45 joule tak boleh guna. You kena buat Newton cm lah. Ataupun yang ni kena convert 0.03 meter. Then we can get 45 joule. Okay. Nak bagi salah, convert dulu kepada SI unit meter. Convert dulu kepada SI unit meter. Then we can get 45 joule. Or 45 Newton cm. Not Newton meter. Kalau Newton meter salah. Okay. Number 4. A spring is stretched with a force of 40 Newton. If potential energy stored is 0.5, calculate the extension of the spring. We have F and we have E. Find X, extension of spring. So we use equation for elastic potential energy, half Fx. Okay, 0.5 joule equal to half 40x. 40 Newton and X. So find X. 20 divided by 0.5. Berapa? 40, 20, 20. 0.5 divide 20.
0.025.
0.5. Oh,
0.
0.025.
Okay, 0.025 unit.
Joule.
Apa pula joule? Extension tu.
cm.
cm.
Joule
cm.
dekat sini. cm. cm ke?
Tahu
Kalau
cikgu.
cm salah.
Meter.
Yes, meter. Ingat kalau SI unit mesti meter. Kita guna joule mesti meter. Mesti meter. So dekat sini nanti tukar kepada meter yang number 3 ni so that you not confuse. Not confused. Sekejap kita tukar. Better we use in meter. So this one is 0.03 meter. Okay, 15 times 0.03 is 0.45 joule. Okay, senang. Tadi dah salah. Tadi guna sentimeter. Okay, yang ni jawapan yang betul tadi 45 tadi salah Okay. B. Determine the spring constant K. How to find K? So K come from F equal to
kx.
Kx. Yes. F we have 40. We also already have X, which is 0.025 meter. So K is 40 divided by 0.025.
1600.
1600. Sure?
40 divided by 0.025.
1600 ataupun 16,000 ni?
16,000.
Belajar fizik kan ada kalkulator lah.
1600 lah cikgu. 1600.
1600 Saya pula kira salah.
1600 ya.
Okay. 1600 unit. Unit apa?
cm.
cm apa pula cm?
Saya mana tahu cikgu, saya tak tahu.
This one we have Newton, this one we have meter. So Newton, meter negative 1.
Okay.
Newton meter negative 1. Boleh Okay, guna SI unit. SI unit for length is meter, SI unit for mass is kilogram. So nak selamat guna SI unit. Okay, done. Habis. Ada soalan nak tanya untuk yang spring? Tengok balik ataupun ambil screenshot. Buat balik. Okay. Boleh hari ni kita habis 12.30. Nak teruskan lagi ke ataupun nak stop dekat sini? Ada nak tanya soalan spring? 17 orang. 17 kan? Okay, Musitong. 17 over 30
17/30.
30. Select. Sekejap Hmm. 18. Okay. Kita stop dekat sini lah dulu. Nak sambung pressure nanti you pening pula.
Okay lah.
Boleh stop dekat sini
Yep.
Boleh ke tak ni? Kan nak sambung lagi?
Banyak cikgu, banyak.
Dah banyak dah tu rasa spring tu. So kita stop dekat sini. Minggu depan hari apa?
Minggu depan.
Minggu depan hari Selasa. Hari Selasa tu saya tak sure ada kelas ke tak. So start daripada minggu depan. Nak kata semua tak juga. Kebanyakan guru duty untuk SPM. SPM next week dah start lah hari Isnin. Doakan abang-abang awak semua tu. Okay. So kalau minggu depan saya duty, Senin Selasa, rasanya tak boleh buat kelas lah. Ataupun nak ganti petang. Petang pun tak boleh. Nanti paper ada petang, susah juga. So nanti saya bagi tahulah kalau yang online
For sure. Okay.
Hari Khamis. Hari Khamis lah. Okay. Boleh dismiss. Nanti jumpa next week Khamis. Selasa tak ada.
Alright. Cikgu, Seko.
Ada soalan lagi? Ada soalan lagi nak tanya? Kalau tak ada boleh dismiss sekarang.
Cikgu, Seko.
Salam. Okay, bye. Okay, welcome. Cepatnya keluar. Aduh. Okay.